Welcome to clickmyproject.com.
Let me discuss about the process. An empirical study for PCA and LDA-based feature reduction for gas identification. Let me discuss about the abstract of the project. Electronic nose system utilize commercial gas sensors for sensing and computer platforms for processing. An integrated gas sensor array, on the contrary, can increase the selectivity and detect multiple target gases with a single device. The central promise when using a feature selection technique is that the data contains many features that are either redundant or irrelevant and can thus be removed without incurring much loss of information. Redundant or irrelevant features are two distinct notions, since one relevant feature may be redundant in the presence of another relevant feature with which it is strongly correlated. Feature selection techniques should be distinguished from feature extraction. Feature extraction creates new features from functions of the original features, whereas feature selection returns a subset of the features. Here, principal component analysis and linear discriminant analysis features are used for performing feature selection process. The number of principal component is less than or equal to the number of original variables. This transformation is defined in such a way that the first principal component has the largest possible variance, and each succeeding component in turn has the highest variance possible under the constraint that is orthogonal to the preceding components. LDA is closely related to the analysis of variance and regression analysis, which also attempt to express one dependent variable as a linear combination of their features of measurements. Finally, decision-tree classifier is used for analyzing these feature selection methods. Let me discuss about the flow diagram for our process. Initially, the gas identification sensors readings has been taken. Gas pipeline testbed dataset is used, which are used to move natural gas or any other petroleum products to the market. The gas pipeline control system contains an air pump that air pump into the pipeline, a pressure sensor that allows pressure visibility at the pipeline. And this dataset comes from the daily measures of sensors in a urban waste water treatment plant. Then feature selection process has been performed. Here principal component analysis and linear discriminant analysis features are performed. Principal component analysis is a statistical procedure that uses an orthogonal transformation to convert a set of observation of possibly correlated variables into a set of values of linearly uncorrelated variables called principal components. The number of principal component is less than or equal to the number of original variables. This transformation is defined in such a way that the first principal component has the largest possible variance, and each succeeding values component in turn has the highest variance preceding components. Next, in the linear discriminant analysis, the LDA is a generalization of Fisher linear discriminant, a method used in statistics, pattern recognition, and machine learning to find a linear combination of features that characterizes or separates two or more classes of objects or events. The resulting combination may be used as a linear classifier. LDA is closely related to principal component analysis and factor analysis in that they both look for linear combinations of variables which best explain the data. LDA explicitly attempts to model the difference between classes of data. Next, the decision tree classifier has been used, which are used for analyzing the principal component analysis and linear component analysis features reduction values. Decision tree learning uses a decision tree as a predictive model which maps observation about an item to conclusion about the item target value. It is one of the predictive modeling approaches used in statistics, data mining, and machine learning. Tree models where the target variable can take a finite set of values are called classification trees. In these tree structures, leaves represent class labels and branches represent conjunctions of features that lead to those class labels. Finally, the performance analysis of the system has been analyzed in terms of accuracy, sensitivity, and specificity. Let me discuss about the running procedure for our process. In our base paper work, they have implemented both hardware and simulating part. In the hardware part, they have generated data set of our gas identification system, but here I have implemented only the simulating part. For the data set I have taken from the website that was mentioned in the base paper. Now in select the main.m file in the current folder, select that file and run for executing this process. This is the main window of our empirical study for PCA and LDA based feature reduction for gas identification. By clicking the gas sensor reading button, we can browse the dataset from the dataset folder. Select any one dataset, and here I have displayed the dataset in table format. Here the entire sensor readings has been displayed, and by pressing the sensor deployment button we have to select no deployment. This is the no deployment of our 100 sensor. This I have plotted randomly, and by pressing the feature reduction button we can move on to the next window. This is the feature reduction process window, and here the test, by pressing the test data button we have to select any one sensor for testing among 100 sensors. Now I am choosing 5, and by pressing the OK button we got the test data, and by pressing the feature reduction button here we have to select any one feature reduction method. First, initially I have chosen the PCA for processing, and this is the PCA train features and also the PCA test feature for our selected sensor data. And by pressing the LDA, here we perform the LDA operation, and also this is the LDA features for our selected data. And by pressing the classification button we can move on to the classification window, and by pressing the decision tree here we have to select any one option. Pressing the PCA we obtain the PCA result. This is the classification tree for our PCA decision tree mapping result, and this is the selected sensor, and here the cost misclassification error, and here the sensitivity versus specificity graph we obtained. And next we select the LDA process. Here this is the LDA classification tree viewer, and here the LDA result, that is the selected sensor, and this is the cost misclassification error, and this is the sensitivity versus specificity graph. By pressing the performance analysis button here we obtain 3 graphs. One is classification accuracy by varying the classification features, and here the sensitivity for our various classification features for both PCA and LDA process, and this is the specificity results for our PCA and LDA by varying the classification features. So finally we analyze the LDA is a best method compared with the principal component analysis, that is PCA method. Thank you.